Well, welcome back, ladies and gentlemen. Working online is something that all of us have had to do a lot more of over the last year. It's why today's conference is coming to you partly from my attic. But car companies are increasingly developing cars from scratch online using shared cloud functions to allow people all over the world to work together simultaneously. Well, in this session, we're going to talk to a startup that has been using that technology to develop its vehicle, and also to one of the businesses providing that, about how it works. Joining me on the virtual stage, Arjo van der Ham, co-founder and CTO of Lightyear, and Colin Clemson from Dassault Systèmes. As always, please do be firing your questions into the chat box, and we will come to those as they come in. Colin, I'll come to you first. Have you seen more and more demand from car companies about moving processes online during the pandemic?
Yeah, hi, Peter. Thank you. Good to be with you. You're right. I mean, clearly, we're supporting, as Dassault Systèmes, we're supporting many established and new automotive companies to overcome the challenges and, I guess, uncertainty presented by the industry, right? By the changes to the industry, of course we are. And the pandemic has seen a significant factor, I think, in accelerating that change. It's placed restrictions, obviously, on all actors right across the supply chain and the value chain almost overnight. I think consumers, engineering, manufacturing, right across the business, sales, marketing, they had no choice, did they, but to work remotely, like you mentioned, and to think and act online. And I think from my point of view, what we've seen is, whilst there's been a workaround for everything, they've all discovered the limitations of legacy file-based solutions. And conversely, companies like Lightyear, Arjo, who joins us here in the panel, they're running their business, as you said, on cloud-based platforms. And they didn't need to transform because it's the way that they've been working since day one. And in our conversations with Lightyear last year, Arjo and the team told us a little bit about how the entire engineering community were working from home during the pandemic, leveraging the technology that was available to them. I feel that with everyone connected, the technology will never be there to obviously replace in-person human interaction, right? That's not what it's about. But it does enable a hybrid model going forward, combining that virtual and real way of working. We've got other examples, of course, and Peter, you interviewed Jaguar Land Rover last year, one of our largest customers, and they talked about how the pandemic had actually accelerated their digital transformation plans. And it's really important to see that it's not just about the startups, it's also about the larger OEMs.
No, exactly. And obviously we've got JLR's current chief executive, Thierry Bolloré, speaking at the conference later this afternoon. I want to come to you. I'm going to ask you about working online, but first, not all of us will have heard of Lightyear. Tell us what it is that you do.
Thank you, Peter, for the intro, and thanks for having me here as well. Quick intro to Liger itself. Liger, a startup company founded in 2016. We're developing a solar-powered car. We have a background in solar car racing for the races in Australia. You can see one of the cars we used to build on the wall behind me. And now we're taking that to a commercial application. We've just built the first prototype. That's driving around. We're building another 10 in this year, and then going live with the first car at the end of roughly the end of this year, beginning next year. You will see the first deliveries of the solar-powered Liger 1. And really, what we are all about as a company is to provide in the long term clean mobility for everyone. And the way we want to achieve that is through efficiency. And we really see efficiency as the key differentiator in the upcoming EV market. If you ask people why they are not buying EVs today, then all the research keeps saying it's about range, charging, and price. And all three of those you can improve by improving the efficiency of the car. So at the heart of what we do is making the car about twice as efficient as the current vehicles on the market. And then adding a solar panel to that as well, which will help you tremendously in the amount of times you need to plug the car in. So make charging a lot better. But the efficiency also helps you to get more range from the same battery and have a slightly smaller battery to get still to a very high range, which allows you to produce at lower cost in the long term, because about 1/3 of the bill of material is still the battery.
Okay, so we'll come on to efficiency and increased efficiency, but I have a few questions related to solar panels on a car. Aren't they incredibly heavy?
It's actually not really the case. So the way we build the panels is by laminating the active part, the solar cells, to a glass top layer. And so actually it doesn't weigh much more than a typical glass roof, and you would see a weight in a typical range of about 10 kilograms per square meter of solar panel, which would be roughly the same as having a regular glass roof on your car. So it doesn't really add weight.
How fast is solar technology developing? Is there a risk when these cars go into production that, say, halfway through their life, you'll need to call them back and fit new solar panels in because the technology will be that much better?
Well, maybe you should see it as an opportunity instead of as a risk in that sense. So the panel we're adding today to the car is already giving you about, depending on your location, of course, but here in the Netherlands where it's not very sunny, we can provide about 70% of the kilometers that the average car in the Netherlands drives, we can charge by the sun. So let's say we get a new solar panel in that's about 35% better, we could cover 100%. So it might be an interesting case for someone to swap those panels out, right? But you don't have to. You still have the 70% of energy in that you had with the original panel. So it's, I'd rather sketch that as an opportunity than as a risk of having to replace it. I mean, as long as that's more about lifetime, as long as the panel works, why bother? Oh.
Yeah. And look, a lot of people, range anxiety is a phrase that all of us are now familiar with, thinking about EVs. Surely if you're driving a solar car and you're reliant on it to recharge to get you to where you're going, then cloud anxiety is more of a thing. Is that right?
I would actually say it tremendously helps with range anxiety. So the thing with range anxiety is, of course, for a large part also the unpredictability. So not exactly knowing when the battery will be empty. We've been working since day one that we used to build these cars for the race in Australia. We've been developing models to accurately predict energy consumption. We've become very good at that. So the first important thing is to be able to always tell the customer, okay, exactly what can you still do with this energy in the battery. Then secondly, we can provide on a 60 kilowatt hour battery 725 kilometers of range on the WLTP standard, which is already a lot more than you would see on most cars currently on the road today. And then you can add to that the fact that you will never get stranded because you have the solar panel. So if you ever do get stranded with an empty battery in a current EV, the only thing you can do is call roadside assistance and have them tow you. With a solar-powered car, you sit there and you wait a little bit until you have enough power to actually make it to the next charging station and then recharge there. So you won't completely get stuck. So I think that the combination of having a long range, a good predictability of actually how much you can still do, and having the solar as a backup will take away most of that range anxiety.
So let's talk about efficiency, which you say is at the heart of the project. How do you get greater efficiency out of the vehicle? I can see, obviously, it looks incredibly aerodynamic. I imagine it's built ground up, so you don't have a kind of legacy platform it has to sit on. But how do you get greater efficiency in the vehicle?
You actually mentioned the two most important parts already. Just to be clear, the car you see behind is the one we built as a student project. It's not the car that we're developing now. If you want to have a look at that one, have a look at the website, Lightyear.one. In the meantime, the key to making a very efficient car is really in the architecture, and that's also where this links together to the software of Dassault that we use to describe those architectures and make very quick iterations and predictions on what actually the performance of such an architecture will be. And basically, what we do is we go back to the fundamental physics and say, okay, where are the losses at, and how can we improve those? And the three most important factors in the energy consumption of the car, the first one is the aerodynamic drag, the second one is the rolling resistance, and the third one is the efficiency of the powertrain. So for all three of those, you want to innovate and do something different to make a great change. In terms of aerodynamics, it really starts in the very early stages of the design process, where you instead of having the design team come up with what kind of car it needs to be based on the market positioning, you start also from the technical requirements and say, this is the energy efficiency it needs to achieve, and we need to achieve a compromise with the design. So we put the designers together with the solar guys and together with the aerodynamic guys in one room to come up with a new exterior shape that has very low aerodynamic drag and accommodates the solar panels, and has good looks and good ergonomics. And making that trade-off is really at the heart of reducing the first big factor, the aerodynamics. Second one, rolling resistance. It's about two things: mass of the vehicle and the performance of the tires. Tires, we don't have much influence on it ourselves, which is why we entered into a partnership with Bridgestone. You can probably find the press release of last week, where we developed custom tires for the Lightyear 1 that have lower rolling resistance coefficient. And second of all, of course, it's about making the architecture in such a way, integrating functions to get to a lower weight of the car. And it's also about this spiral. So if you make the car lighter, it uses less energy. You need a smaller battery. Car becomes lighter again. You can have smaller motors to achieve the same acceleration performance, which makes it lighter again. And you enter into this sort of lightweight cycle of making the car lighter and more efficient. And instead of I need more range, so I'll add more batteries. Car becomes less efficient, add even more batteries, etc. So trying to run that loop the other way around towards a lighter car.
And how much? So go on.
No, well, the third one is the efficiency of the drivetrain. So the third big important part. And what we did there is we went for a concept with 4 individual in-wheel motors in each individual wheel. And that allows us to get rid of a lot of the mechanical losses that otherwise would be associated with the drivetrain. So there's no drive shafts, no final drive, no gearbox, etc. in between that would introduce extra losses. It's really direct drive. And then we also developed in-house silicon carbide-based inverters for those motors to have really the highest efficiency you can think of going from the battery towards the wheels.
And how much of this efficiency, and all the things you've talked about were helped by being able to do everything online collaboratively from scratch?
I would say it's one of the key things to make this happen is to have an environment where you can play with the architecture, very quickly build a concept, simulate its performance, and assess and readjust. And if you would do this in a traditional way, making diagrams and writing the requirements in a Word document, and then if you have to change something, it's just too much work. While if you want to optimize, you want to continuously keep changing and adjusting all of those targets and make sure that everything's linked together to make sure you still meet the constraints to get to this point. So basically, we treat engineering as an optimization problem. So we define an objective function to maximize. In this case, for the first Liger 1 car, that optimization function was that objective function was the amount of kilometers you can drive each year on the power of the sun. And so you want to increase the solar area, the efficiency, and decrease the energy consumption of the car. And all of that ties into increasing the amount of kilometers you can drive each year on the sun. And it means that you don't have a set target at day one for the aerodynamics. You don't have a set target for the weight, but you want to continuously make the trade-off. Is it better to add a bit of weight and make the aerodynamics better? Or is it better to do it the other way around? And you want to keep doing that as long as possible throughout the entire design process. So, and only freeze something once you have a concept that works as a whole, instead of freezing top-down similar things. And the only way to do that is to have this collaborative environment where everybody can see continuously where you are at, how everything ties in together, what are all the interfaces, and if I change something here, everybody should immediately know what's happening somewhere else. So there has to be one single source of truth for all of this.
I want to bring Colin back in at this point. A lot of car makers, Colin, particularly the established ones at the moment, are facing a pretty tough time, right? Industrially, it's difficult with the chip crisis. Demand is still not at pre-pandemic levels. They've got a lot of challenges, decarbonisation, everything coming on. What advice would you have for car makers if they're looking at doing something like this, but they are facing a lot of short-term, very expensive challenges they have to navigate as well?
So, from our perspective, it's interesting to obviously to work with Arjo and the team at Lightyear, around that optimization piece. Optimization is critical, right? And optimization of your resources, everything around the vehicle is so important. And, we've got one great example here about Lightyear in terms of how they optimize the entire architecture of the vehicle. There are other examples, right? Other companies such as BMW, for example, using our technology in a very specific way. There's examples out there that you can read about, where clients have taken our technology to optimize capabilities and solutions around, particularly in the area of defrosting is one example from BMW, where they selected our technology to provide the optimization between the acoustic and design performance and focused on reducing noise. So you can use the technology on a wide scale, as Arjo's described here, in terms of architecture and ensuring that the right architecture is designed for the vehicle, but in a much more focused way as well to deliver the right solutions for the end customer. Other examples, Furusha, their challenges around production rates, and they use the technology really to look at how they could unify methods, processes, and data across all disciplines and really bring together design, engineering, manufacturing, and virtually simulate those production lines, ensuring that they can save time, reduce costs, of course, and enable them to ramp up more efficiently. Also, on top of, that's from a technology point of view, but if we think about what we're really about as Dassault Systèmes and what we're really focused on is sustainability. And sustainability plays such an important role now, hence, the work that Arjo and Lightyear are doing again around the solar car. A more sustainable world and more sustainable businesses are really two sides of the same coin, Peter, right? And one drives the other. And I think many business leaders now have already recognized the opportunity to connect business sustainability into the way that they operate. So we focused as Dassault Systèmes on 3 pillars, Peter, and that, sustainable business models, how can we help business define new business models and business approaches, products and services, how can we put efficiency at the heart of innovation, using the technology for visualization and simulation, of course, but also sustainable people. Right? People is so important for our businesses to ensure that we've got the knowledge and know-how captured in our business so that Arjo and Lightyear can take advantage of that knowledge as the next vehicle comes online. But also we can attract the workforce of the future as well.
Perfect. I mean, it's interesting you raised the question of workforce. Arjo, has been able to do things online, do things remotely. Has that changed the types of people you can hire and where you can hire them from? Because it means you don't need to convince, someone from, California or Berlin or anywhere else to move to somewhere they may not necessarily want to.
Definitely, and this is something we've picked up since the beginning of the pandemic, and we are now running a pilot by having people actually not moving but just coming in, maybe depending on the role, maybe once a month or once a few months, actually over to the Netherlands, and doing the rest of their work from their original home, and that's looking very successful so far. We are even doing that as well right now with one of the critical roles in the organization. So our vehicle level project manager for the first car we are developing is working from the UK, and it definitely opens up a much bigger talent pool and to be able to attract to get those people in. But it's also a challenge, because on the other hand, you do still notice that we can't do everything. We can't do everything virtually in the sense of personal contact, creative sessions, coming up with ideas. You sometimes do need to still be here. Also, of course, some physical testing and building prototypes. A lot of that you can also play around with. So we did already quite a lot of testing where the software engineers are just all over the world and controlling the test setups from their home. And there's just one technician sitting in the lab and maybe reconnecting some cables if they need to measure something else. So all of that you can do. But once you have to do some creative troubleshooting or come up with a new solution, you do notice that it's still valuable to actually have the people on the ground in the lab to come up with a creative way of solving something. So it's definitely opening up new possibilities, but it's going to be a hybrid. It's for a company that's building a physical product, it will never go 100% virtual, I would say.
No, exactly. We had a great question that's coming from the audience here, which is again for you, Arjo. Will you be able to use your Lightyear one to power your house or to store electricity for alternate uses? I know a lot of people are talking about sort of two-way charging for EVs and what that might do.
Yeah, you actually will. So it's going to have also a 220, or depending on where you are in Europe, 220 socket to power other stuff. And bidirectional charging. It might not be on the first vehicle ready yet, but we're working very hard on it. So it's definitely going to be a part of it. And
perfect. Thank you. Final question, because we're almost out of time. Look, as other big OEMs increasingly move stuff online, and their electric vehicles then become more efficient, is that how much of a risk is that to you guys that actually the big established players who have big production facilities and retail networks and established brands and all these things actually catch you guys up in terms of efficiency?
I can answer this question from a personal point of view and from a company point of view. So let's start with the personal one. And we really started this company to make this world a better place and move over to clean mobility for everyone. So I'm just really, really happy when I see that happening and when I finally hear people making the changes, because I also hear the other stories of OEMs still ordering 30 million gearboxes for ICE cars in 2030. And I'm like, how? But so I'm really I'm happy on a personal level. On a company level, I think we're so far ahead in terms of efficiency. We're doing a factor 2 better than anything that's on the market right now. We don't see that changing. Also because a lot of it ties into the brand value that you already have built up, and it takes time to change something like that. If we take a look at Tesla, for example, it's going to be very hard to put a car out that does not accelerate in 5 seconds from 0 to 100. But if you don't do that, it's going to save you 300 kilograms and quite some energy. So it's also about making choices and what your brand image is and what type of product you want to build and be, and still have an advantage there. So if you look historically at Tesla, then, for example, just taking them because that's practically the most efficient car out there right now, and they're improving at a rate of about 3% a year. So if you have a factor 2 head start in terms of efficiency, we're not so worried.
Perfect. Thank you. Look, fascinating session there. Thank you. I'm afraid we're out of time. Colin, Arjo, thank you so very much. That was a great discussion there. Still lots more to come. This afternoon, we have the Chief Executive Jaguar Land Rover and the UK's Transport Minister. Later this morning, we'll be talking about changes of talent in the industry and what that looks like. And after the break, we'll be hearing from Carlos Tavares, Chief Executive of Stellantis. That starts at 11 o'clock UK time. We'll see you then.